Okay, and here I have given, you can see that there are three type of work part transport systems. One is a continuous transport system and synchronous transport system, asynchronous transport system. These are very important. With a neat figure, we have to explain all this. Okay. Under this continuous transport system, overhead trolley conveyors will be coming, and the belt conveyors will come, and roller conveyors will come, drag chain conveyors will come. Continuous transport. As the name indicates, continuously the work will be transporting by means of roller conveyors or belt conveyors or the drag chain conveyors. Okay, these four type: drag chain conveyors, roller conveyors, belt conveyors, and overhead trolley conveyors. The figures I'll be discussing later. These will be coming under continuous transport system. And synchronous, as the name indicates, the synchronous, it will be synchronized. The synchronized between the workstations and the work transport systems. Okay. Under this, we have walking beam transport equipment, very important. Around 80 to 90% we can hope on this. With a neat sketch explain any one type of synchronous transport system or simply walking beam transport equipment and rotary indexing mechanism. There will be two types: synchronous you take or asynchronous you take. Under them will be having linear and rotary. Okay, so in under the synchronous transport system, walking beam transfer equipment, it is a linear and rotary indexing mechanism. These two will be coming. And asynchronous, power and pre-overhead conveyors, cart and track conveyors, powered roller conveyors, automated guided vehicles, and monorail systems and chain drives at bedsides. All these will be coming another asynchronous transport. As the name indicates, asynchronous indicates there is a not synchronized mechanism between the work part transport systems and the workstations. When the workstation complete, the automated guided vehicle will be moving on its track, take and send it to other stations. These asynchronous transport systems will be used for the machines which are workstations which are kept at a larger distance. Okay, that time it may not be possible to have any type of conveyors. We are going to use these type of systems. And let me come to the system configuration. See, linear mechanisms, the linear inline mechanisms I'm discussing about. I'm discussing about the linear inline mechanisms. Okay, so these linear inline mechanisms, they are more flexible. They are more flexible means we can change some configuration. They permit quicker queues of parts to form between the workstation to act as a storage buffer, because these conveyors will be larger in distance and more number of work parts can be kept on them, and they'll be self-acting as a buffer storage units. So in the previous class, I have discussed about the buffer storage. Buffer storage will be provided in between the workstations. The buffer storage unit will be storing the extra unfinished product coming from one station to the other station, and it is easier to rearrange and expand the production line. One of the important features of this linear systems are more flexible, and they can permit more number of parts to be accommodated on them, so that they can act as self buffer storage units, and it is easier to expand and rearrange the production line. Under this, we have the work part transport systems. Are three types. We have three types of work part transport system configurations. One is inline, segmented inline, and rotary. You are hearing me?
Yes, sir.
Yes, sir.
Yeah. Inline, segmented inline, and rotary systems. See, the name looks slightly complicated, but it is very simple. You can see this: the inline L shape, inline U shape, inline rectangular shape. Inline means on a single line, all these production unit, the workstations will be arranged. You can see that the production automated system 1, 2, 3, these are the different workstations. The work part will be starting from the raw material will be entering here, and the finished part will be taken from this. Since the orientation of this L line transfer system is kept in the fashion of L shape, so that it is called L shape. And the U shape, the belt conveyors and all these will be used in the U shape. The processing units, the workstations will be kept in the U shape, and the work part will be starting from here, and the completed work part will be taken out from here. And this is rectangular shape. You can see that rectangular shape. And these conveyors, what happens, these are the work carriers, and you can see this rectangular blocks shows work carriers. These work carriers will be designed specifically for to hold the finished and unfinished work parts. For example, on an engine, there is an engine, the main base part engine. On this main base part engine, we are going to do assembly of 10 assemblies. For example, you take here 1, 2, here you can take the 1, 2, 3, 4, 4 plus 4 plus 2, 10. There are 10 workstations. The engine enter from here. On each workstations, a specific job will be performed on the engine. The assembly will be done, and at the end, the finished completed engine will be taken out. Since this is in U shape, it is called U type inline, and it is L type inline, and it is rectangular type inline. This rectangular type inline, all these will be used specifically some limitations of the workspace. And this inline, whatever the way you want, you can design them so that in available space we can have, or we can arrange the automated flow line, so that the effective utilization of the workspace with a minimal workspace can be done. And you can see here in rectangular shape, the work part will be entering from the left, and the processing will be done at each stations, and completed part will go, and the work carrier will again come to this point, and it will be some washing machine or washing station or some other station will be there, and there it will be washed and it will be entering. And this specific type of systems will be used for the chemical processing industries. The chemical processing industries, the parts will be assembled here, and any dirty or any oily skipping things are on the conveyors, those have to be, or painting, those have to be cleaned. The cleaning will be done on these carriers, and again it will be coming to this point. The work part will be kept on this, and it will be continued. Okay. In the inline type, we have, please remember, explain any inline processing unit. So L shape, U shape, rectangular shape, and these effectiveness. What are the advantages of using this? Here you can see that the effective utilization of the space, the space utilized for these will be very limited, and whatever the way you can do the design, you can reorient them. And in some of the cases, this L shape and U shape will be very essential for reorienting the parts. You can see that, for example, the part is entering here vertically, and once it come here, it will go down horizontally, and again it will be reoriented vertically. Once if you have to do any processing by reorienting the base part, that time the L shape, U shape, and the rectangular shapes will be very useful. Okay, these will be very useful, and that is what I have given here. The segmented inline configuration consists of 2 or more straight line transport sections, where the segments are usually perpendicular to each other. There are number of reasons for designing a product line in these configurations rather than the pure straight line. Available floor space may be limited in the length of the line, and work piece in the segment inline configuration can be reoriented to present the different surface of machining. And okay, here I have already explained the effective floor space can be utilized. Since the inline is offering very lengthy space, since the lengthy space is required, the factory space requirement will be very large. So that time we can segment them into number of parts and we can reorient these work parts on the different passions on these work lines so that the minimum workspace can be used. And the second point which already I have told, you can see this, the work part can be reoriented many times. Here I can reorient the work part 3 times. Sometimes I have to assemble some parts on the top. Sometimes I have to assemble the parts on the vertical space. So that time the top side and again reorient the work part and horizontal surface on the sides and again on the top. So and the different orientations we can do the assembly and some other processing operations by reorienting the parts on this. So that is what the rectangular layout provides the shift return of the work holding picture in the front of the line for reuse. So here this is, as I told you, this rectangular shape will be specifically used for the dirty spaces wherein the conveyor have to it has to be cleaned properly before the work part is kept on this. Just like in the painting space, spraying space, and in some other chemical processing industries, some of the dirty will be placed or located on the work holding devices which are fixed on the conveyors, so they don't have to be cleaned. So that time we can use this particular rectangular type of systems. Okay, and other one, the 2 segments, as I told you, the inline it will be offering many type of designs, and here you can see that one U shape and another one is the straight inline processing unit will be used. And here you can see that this is a rectangular shape. What happens? These are the work carriers. The work carriers will be moving and the raw material will be taken here. You can see that this is one type of automation. For example, it is the main part. These are the sub parts. These sub parts have to be arranged on the main parts. Here we are going to use the rectangular inline transfer mechanisms. And here the work part will be loading from this station and it will be coming here, and some washing or some other processing will be done here, and it will be coming up to this point, and from the right end the sub part will be entering. The sub part will be entering and it will be assembled at this location, and the completed parts will be taken out. Here you can see that the completed parts will be taken out and the work area will be again moving here. The work will be located onto this. So this is how the 2 different inline, maybe it is a rectangular U shape or the L shape. These can be integrated together at different passions based on the design which we require or offering for the automation process. And these are about the